Good morning students. Welcome to the YouTube channel of Little Flower School Raptinagar. I am Amit Kumar, your computer science teacher, and this is the 6th video lecture for class 11th A and 11th B. In our previous 5 lectures, we have actually dealt with our numbers and encoding chapter of our section A of our syllabus. And today we are going to start the 3rd chapter of section A, that is Propositional Logic, Hardware Implementation and Arithmetic Operation. So it is Propositional Logic, Hardware Implementation and Arithmetic Operations. So the objectives will be displayed on your screen right now. So you can see we are only going to deal with propositional logic today. We are not going to deal with hardware implementation and arithmetic operations. That we will deal in the upcoming video lectures. So the topics that we will discuss today will be propositional logic, well-formed formula, truth tables and truth values, and interpretation of well-formed formulas with truth table. We are also going to see few definitions related to this topic. And let me tell you, this topic is very important not only for your 11th perspective but also for your 12th syllabus, because this is going to form a base for your 12th class. So the second part of this chapter itself is logic and hardware and some arithmetic operations over it. So that part we are not going to deal today. So that was our objective. I hope the objective is clear to you all. So now let's start our chapter Propositional Logic. I have gone through the doubts also, actually only one doubt being raised after the last video lecture, and that was also related to a mistake that I have done. Actually hurriedly I have written over there like 2 to the power 1 and I calculated it as 1 instead of 2. So the student asked, sir, it should be 1 or 2, so it has to be 2 only because 2 to the power of 1 is 2. So that was a mistake in the calculation if I have written it as 1. So hurriedly maybe it happened. So I hope that would also be clear now, and let's proceed to the topic propositional logic. Now the first question that may arise in your mind is, what is a proposition? Okay, so a proposition is any statement that results in true or false. So any statement that results in true or false are known as propositions. So let's take an example. Are you going? Is this your home? Is this your pen? Are you Rahul? And there can be different questions like that which can be answered in true or false. But there are some certain statements which cannot be answered in true or false, like, okay, when did you came? Or what's your name? How are you? They cannot be answered in true or false, right? So the statements whose result is always either in true or false are propositional statement or proposition. They always result into true or false. Now there are some properties related to propositions. Each proposition follows some properties. So these properties you should remember. So what are propositions if someone asks? So all the statements that results into true or false only and no other results are known as proposition or propositional statement. Now what are the properties of proposition statement? So they cannot be anything. The result of these, the first property is the result of these statements cannot be anything other than true or false. So this is the first property. The second property says that it can be connected, right? One or two propositions can be connected together with help of some operators, and that leads to another proposition. So two or more propositions can be combined together to form a new proposition. All the propositions are represented in uppercase alphabets. So you can represent a proposition like A, B, C, and you can give the statement, whatsoever statement that proposition is. It is raining. Okay, it is raining. It is Rahul's bike. You are studying. Now all these can result into true or false. And you see all the propositions are represented in uppercase alphabet. So first of all, the first property was it cannot result into anything other than true or false. The second property states that two or more propositions can be combined together to form another proposition or a bigger level of proposition. And third one is they are represented in uppercase letters. The last property of a proposition is the result of a proposition states, or the result of a proposition can be represented with help of truth tables. So these are the four properties of a proposition. So I hope you understood now what is a proposition and what are the various properties of a proposition. Now the next topic to be discussed is truth table, but here I want to tell you one more thing about proposition, that is its types. Though the types of propositions are not part of your syllabus, but you should know that there are basically two types of propositions which are known as simple proposition or compound proposition. So you can see these three are simple propositions because they are only a single proposition. So a proposition which is resulting into a true or false, a single statement, is a proposition or simple proposition. But if you are combining two or more simple propositions together, the proposition that you are forming is a compound proposition. So today we will see how we can form a compound proposition later on in today's video lecture itself. But before that, the next topic to be discussed is truth table. Now the question is, what is a truth table? Now a truth table is a table that shows all possible values of a proposition. So truth table is a table, so of course it will have some rows and columns. So with the help of some rows and columns, if you are able to show all the possible values, all the possible combinations, all the possible answers a proposition can have, then the table that you are using is a truth table. Truth tables are used to evaluate a proposition. Even in Boolean algebra we use truth table. Now let me tell you how we can form truth tables with a single proposition, with two propositions, with three propositions, or with four propositions. So we will see that, but before, let me tell you, here the result of the proposition, that is true or false, is stated with help of binary numbers, that is 1 or 0, where every 1 is actually representing a true and every 0 is actually representing a false. So the true or false will be represented in form of 1 and 0. So let me show you a truth table. Now this is a truth table for single variable. Now if I am having a single variable, right, if I am having a single variable, there are only two possible values it can have. The single variable can be true, or the value of single proposition can be false. So this proposition can be true or this proposition can be false, right? So how it would be represented? If it would be true, this proposition will be represented as 1. If it is false, it will be represented as 0. So this is a single proposition or a single variable truth table. But if there are two propositions, right? If there are two propositions, let's say A and B, and there can be chances when both the propositions are false. There can be a situation when the second proposition is true and the first proposition is false, or the first proposition is true and the second proposition is false, or the last combination is when both the propositions are true. Now how many possible combinations will be there? It depends on the number of propositions. So 2 to the power of number of propositions. So if number of proposition is 1, okay, so definitely 2 combinations will be there. If number of propositions are 2, there will be 4 combinations. If number of propositions are 3, there will be 8 combinations. And if number of propositions are 4, there will be 16 possible combinations. So right now there were 2 propositions, so the possible number of combinations were these 4 combinations. Of course the result will depend, okay, how we are using these propositions together, and soon we will realize how we are going to combine propositions. Then the result will depend on that. Okay, so we are not forming the result part or the column that will tell you the answer. Actually we are only forming the input column, not the output column. So these will be the possible input columns. So with two propositions, there will be 2 input columns. With 1 proposition, there will be 1 input column. With 3 propositions, there will be 3 input columns. With 4 propositions, there will be 4 input columns. Now how many rows will be there in each proposition? So that will be 2 to the power of n number of rows. So if 1 proposition there, 2 rows. If 2 proposition there, 4 rows. If 4 proposition there, 16 rows. So that's how you are going to form the table. Now what about the possible values you write over there? So well, if you write the binary numbers in normal way, no, so you can get these values. Otherwise, I told you, if you don't remember the binary numbers in the sequence, I told you the shortcut: write down the variables or write down the propositions, and from the right hand side start with the gapping of 1, so 0 1 0 1, and now start with the gapping of 2, so 0 0 1 1. Now if any another variable will be there, we will have a gapping of 4. So this is how you are going to form a truth table. Now I am showing you a truth table for 4 variables. You will make a truth table for 3 variables by yourself. Okay, so let's see a truth table for 4 variables. So let's see, the variables are A, B, C, D. Okay, so there will be 16 combinations. So it will be 0 1 0 1 0 1 0 1 0 1. I haven't counted. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, right? And similarly gapping of 2 here, and you will move on like that. Gapping of 4, and you will move on like that, and gapping of 8, and like that. So this is how you can form a truth table with 4 propositions as well. So I hope you understood what is a truth table. Truth table is a table which shows all the possible values a proposition can have. Even in case of any operations, it shows the result of the operation. So that is a truth table. Now how to represent a truth table? I hope you realize that. What will be the number of columns? So the number of input columns depends on the number of propositions. How many rows will be there? So the number of rows depends upon the 2 to the power of number of propositions. So this was the truth table. Now the next topic that we are going to discuss is connectives. Now the question is, what are connectives? So we have seen what is a proposition, we have seen what is a truth table, and now we will see what are connectives. And there are actually 5 different connectives that we are going to study. Okay. So now the question is, what are connectives? Now connectives are actually operators or symbols which are used to combine simple proposition and form a compound proposition. So with the help of connectives, you can combine simple proposition and definitely you can form a compound proposition. Now how many connectives are there? There are basically 5 connectives that we are going to use, and how they are combined, how propositions are combined, how a compound propositions are formed, I will tell you. But among these connectives, there is only one operator, because it doesn't combine the proposition. Now that one is our first connective that we are going to study, and that is negation. Okay, negation is a connective or an operator, also known as not, or we also say it as complement. So negation, the interesting thing about negation connective is it works on a single proposition. So it cannot combine 2 propositions, only one proposition it will work with, and it will complement, it will negate that single proposition. For example, if the result of the proposition is true, so this will negate it and it will become false, and if the result of the proposition is false, so this will make it true. Okay, for example, if a proposition is there P, saying that I am studying, so you can form a negation of the P. Now there are few symbols that we use. This tilde symbol can be used, or a dash symbol can be used, or sometimes we use a bar over the variable. So you can write it as tilde P, or you can write it as P dash, or you can write it as P bar. So it's up to you. So negation of P will be I am not studying. Well, that's not true, I am studying, but let it be. The negation of this proposition will be I am not studying. and how you will represent it in truth table. So suppose we are representing it in truth table. So there is one input, one proposition, so there will be one input column and one output column. Now input column is the proposition itself, that is P. Output column is P dash or negation of P. Now there are two possible values P will have. P can be 0, P can be 1. So if P will be 0, P dash will be 1. If P will be 1, P dash will be 0. So this is the truth table representation for the negation connective, one of the easiest connective and one of the simplest connective that we are having. Actually all the connectives are simple, so don't worry about it. The next connective that we are going to study is conjunction. What it is? Conjunction. So let's see. Conjunction connective is also known as AND. So for example, for negation, this is known as not P or P not. So AND is a connective which is actually work on two propositions. So you can take two propositions, you can combine these two propositions with the help of conjunction, and you will say it as suppose A connective is it is raining, and B connective is I am playing. So if you are combining them, it will be as A and B. So what are the symbols? There are two symbols with AND. We can use this symbol, A without a dash, and or you can use a dot symbol. So any one of them. So it can be A and B, or it can be represented as A and B. So whichever you like. So the result of A and B will be it is raining and I am playing. It is raining and I am playing. So this will result into true when both of them are true, as we have used AND. So it will return true if both the propositions are true, and if any one of them is false, the AND connective or the conjunction will result into false. So let's see that with the truth table. Because there are two propositions, so there will be two input variables for them, and there will be one output. Okay. So now the input variables are A and B, and output will be represented as A and B. Okay. So the possible combinations are 0 0, 0 1, 1 0 and 1 1, and we know AND will return into true when both of them are true. So there is only one case when both of them are true. So for rest of the cases it will be false. So this is a truth table representation for a conjunction operation or an AND operation. So this was the second connective that we were going to study. Now let's move on to the next connective, that is disjunction. Now disjunction is just opposite of conjunction. If you remember the logical operators of programming, then AND, OR and NOT are actually related with conjunction, disjunction and negation. So the next one is disjunction, also known as OR. It is represented by reverse of conjunction symbol or plus. So we can use any one of them. Now disjunction operation is also used to combine, to connect two different propositions and result into single one, and it gives, so if the previous case was there, so it is like, suppose A is I like tea and B is I like coffee. So A or B will be I like tea or I like coffee. Now here in this case, if any one of them is true, it will be treated as true because OR is used here. And in that case, the truth table representation for the given connective will be like this. So it will be 0 0 0 1 1 0 and 1 1, and that will give true if any one of them is true, and that will give false if both of them are false. So there is only one case when the disjunction connective will give you a false result, when both the input propositions are false. If any of the input proposition is true, it will give you a true result. The next operation is conditional connective. Conditional connective. Now conditional connective are also known as implies connective or if then connective. Okay, implies connective or if then connective. Okay, so let's see. It is also known as implies or if then connective. It is represented with this arrow symbol, and if you are having two connectives like A implies B, so it will be called as if A then B, if A then B. Okay, so of course in this case there are two connectives that there are two propositions that it will combine. And let me tell you, in case of conditional, in case of implies, both these propositions have name. This is known as antecedent, okay, and this is known as consequent. Antecedent and consequent. You got that? So for conditional connective, the consequent have to be true if the antecedent is true. Okay, the consequent have to be true if the antecedent is true. If the antecedent is false, no matter consequent is true or false, it doesn't matter, result will be true only. So if antecedent is false, consequent is true or false, doesn't matter. So if antecedent is false, the result will be true itself. But in case if the antecedent is true, then the consequent has to be true, otherwise the final result will be a false. So let's see a truth table representation. For example, A and B connectives are there. A and B propositions are there, and A implies B connective is used there. So the four possible combinations are these. Now I told you, if antecedent is false, it doesn't matter consequent is true or false, that will result into true. But if antecedent is true and consequent is false, so that is the only case where it will false, otherwise it will be true. So the only case where a conditional operation will give you a false result is when the antecedent is true and the consequent is false. So we can treat it as if father is at home is the first connective, I will study is the second connective. So if father is not at home, I am not studying, no issues. If father is not at home, I am studying, still no issues. If father is at home, I am studying, still no issue. So there is a case where there will be an issue if father is at home and I am not studying. So this is just an example to tell you what are conditional connectives. The next and the last connective that we are going to study is biconditional connective. Biconditional connectives are also known as equivalence connective. Okay, so let's see. And the symbol for this is double-sided arrow, almost like equilibrium symbol in your chemistry, almost like, not exactly but almost. Now biconditional equivalence. So if here also if you are treating antecedent and consequent, but they are not. If the first proposition and the second proposition both are true, and if both the proposition are false. So if both are true, it will result into true. If both are false, it will result into true. That means if both are same, this connective will result into a true. If both are not same, both are different, it will result into a false. So very simple, just to show you, and then I will tell you if conditional, if you want to work with conditional, there is a shortcut also. You can take help of that shortcut and you can work with conditional if you are unable to remember. So see, when they are different, result is 0. When they are same, result is 1. So this is your biconditional. So these are the 5 connectives with the help of which we can combine propositions and we can create a compound proposition. Actually, out of these 5, one cannot be used to compound, to combine the propositions, but the rest 4 can be. Now the conditional can also, we can also get result of a conditional by replacing it with a negation and a disjunction. For example, if A conditional B is given, now you know the result of it. The same result can be obtained by A complement plus B. Okay, let me show you. So let's see the result of A complement plus B. So let's have A, B and A complement. So B and A complement. So this is A complement plus B. Fine. So 0, 0, 0, 1, 1, 0, 1, 1. So A complement will be 1, 1, 0, 0. Now let's add them up. So 1 plus 0 is 1, 1 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1. So you are getting the same result that you would get if you would use implies. So instead of using conditional, if this is confusing for you, you can work with this and that will also give you the same result. So in case in examination they ask you to create a truth table for the conditional, or they have given you a conditional, they have given you a truth table and they ask you whether it is conditional or not, you can verify it with this one also. So these were the connectives that we are going to study today, and I hope now you understood these connectives and the truth tables and the result that these connectives give. Now the next topic that we are going to discuss today is propositional definitions. So there are 14 terms that I am going to define you, and then in today's lecture we will see few exercise questions that I have given you. You can treat it as your assignment, as your homework assignment, because I think this is the last video lecture and now we will come to the next video lecture. Let's see, I think in July, I'm not sure, but you will be notified about the dates. So whensoever our next lecture will start, we will continue, whether it's going to start online or it's going to start in the school, we will continue from the next topic itself. If you are having any kind of queries in propositional logic and you want to ask, you can raise the query in the same query submission link. I will get the query and definitely I will try to resolve it as soon as we will get back with our lectures. So please complete these exercises, and if you are unable to do any of them, at least try, so that whenever I will tell you how to solve it, you will get it very easily. So today I will tell you those exercise questions, but let's first see these 14 terms and their definitions. So these 14 definitions are very important. Sometimes they ask you in examinations to define them. Sometimes they even give you a statement, a proposition, a compound proposition, and they ask you to prove with truth table like what kind of proposition it is. So for that also you should know these definitions, then only you can tell what kind of proposition it is. So the first definition is well-formed formula. WFF, also known as WFF, well-formed formula. Now what are well-formed formulas? You know what, all the propositions that are clearly giving result in true and false are well-formed formulas. So the propositions are well-formed formulas, no doubt. And you know what, there are some well-formed formulas. So all the statements are well-formed formulas which are following these rules. The first rule itself is it should be a proposition. So if it is a proposition, it is a well-formed formula. Any connective used on a proposition will also be a well-formed formula. I mean to say, if A is a proposition, then negation of A is also a well-formed formula, because A is a proposition, hence A is a well-formed formula, no doubt. And negation of A is actually a connective on the proposition, so hence it is also a well-formed formula. and anything else other than this is not a well-formed formula. So any connective used on a proposition is a well-formed formula, a simple proposition is a well-formed formula, and anything other than this are not well-formed formula. The next one is tautology. The next term is tautology. Now a given proposition will be a tautology if it is always resulting 1. So all the output, whatsoever output it is showing, all of them is resulting into 1, then definitely the given proposition is a tautology. For example, a plus a complement. If you are going to operate on this, it will always give you 1. You want to check it out? Let's see. A complement and a plus a complement. So 3 columns we made. So 0. So if a is 0, a complement will be 1. If a is 1, a complement will be 0. Because only one input variable is there, right? So only 2 possible combinations. Now a plus a complement will be 0 plus 1 will be 1, 1 plus 0 will be 1. That means a plus a complement will always result into 1. Hence a plus a complement is a tautology. So any proposition that is always resulting into 1 is a tautology. Now the reverse of tautology, it is known as contradiction. Contradiction. Okay. Now what is a contradiction? If a given proposition is always resulting 0, okay, if the result of a given proposition is always 0, then it is nothing but a contradiction. For example, a and a complement, it is nothing but a contradiction. Okay. The next one is contingency. Now if the proposition is resulting into 1 and 0, so there in the result there are 1, there are 0, so it's a combination of 1 and 0s in the result, then it is nothing but a contingency. So I hope tautology, contradiction and contingency is clear to you, because this is one of the most important thing that they ask in examination. They provide you a proposition, a compound proposition, and they ask you via truth table to prove whether it is a tautology, a contradiction or a contingency. So with the truth table you will find out the result, and then you will see if the result is only 1, then it is a tautology. If the result is only zeros, then it is a contradiction, and if the result is combination of zeros and 1, then it is contingency. The next one is satisfiable and unsatisfiable proposition. So let's see what are satisfiable and what are unsatisfiable. Unsatisfiable. So all those propositions in which it is having any one. So if in the result of the proposition, suppose this is the truth table, these are the rows, and this is the result column, and in the result column, if any one is there, if any of the row is resulting into 1, any one of the row is resulting into 1. So it's not like all of them should be 1. If any one is there, still it is satisfiable. But if all of them are 0, then it is unsatisfiable. So you can see a contradictory statement is unsatisfiable statement, because a contradiction will always result into 0, there will not be a single one. So if there is a single one in it, it is satisfiable. If all of them are 0, it is unsatisfiable. So I hope these 6 definitions are clear to you, and we can move on. Okay, so let's see the 7th one. The 7th one is premise or premise. So any proposition that is resulting into any kind of conclusion, so any proposition that is giving you any kind of conclusion is a premise. For example, 6 is greater than 5. 6 is greater than 5. This is a premise. Why? Because this is a statement, of course. 6 is greater than 5. It can result into true or false. So this is a proposition, and of course it's true, and it's also concluding us something. Like what it is concluding us? It's concluding us like 5 plus 1 is 6. We can conclude from it like 5 plus 1 is 6, because we know that 6 is greater than 5. Okay. Syllogism. Now what is syllogism? Syllogism is when two premises, this is the next definition, when two premises are there and combination of them or they both are actually giving a conclusion. So the combination or two different premises are giving you a conclusion, then definitely it's a syllogism. For example, let's see, all students are good and you are a student. That means you are good. So if first proposition is all students are good, second proposition is you are good, so let's consider them as two premises. So the combination of them is resulting all students are good, which is actually a syllogism. So if two different premises is concluding something, it's a syllogism. Now chain rule. The next one is chain rule. It says that if P implies Q and Q implies R, then P implies R. Okay. Now suppose P is if you will study, Q is you pass exam, R is you get job. So if you will study, you will pass exam. If you will pass exam, you will get job. So if you will study, you will get job. So this kind of result is known as chain rule. Okay. The next one is modus ponens. Modus ponens. Now what are modus ponens? It is actually related to again conditional. Now we know in conditional statement one is antecedent and one is consequent. So here P is antecedent and Q is consequent. For modus ponens, antecedent is true, then consequent has to be true. So if antecedent is true and consequent is true, definitely it's a modus ponens. So all the valid, you can say all the valid conditional statements are modus ponens. Okay. The next one is converse. The next two which I am giving you is very important for examination, because converse and inverse they ask many times in examination, of course in 2 marks only, but this is something they ask many times, converse and inverse. So let's see that. Suppose P implies Q is a statement, then converse of it will be Q implies P, right? And in inverse, if P implies Q is a statement, then inverse of it is P, negation of P implies negation of Q. So I hope you understood the converse and the inverse. Converse, so antecedent becomes consequent, consequent becomes antecedent, that is converse. But antecedent remains antecedent, consequent remains consequent, they all just turn out to be in negation, then that is nothing but an inverse. Now the next statement that we are going to discuss, next two definitions that we are going to discuss is consistent statement and contrapositive. 13th one is consistent statement and 14th one is contrapositive. Okay, let's see. Okay, so consistent statement. So do you remember tautology? Okay, so all the tautologies are consistent, because for any statement to be consistent, the result should have all ones. So if the result is having all the ones in it, it is a consistent statement. That means all the tautologies are consistent. And last one is contrapositive. It is just opposite of modus ponens. That means if consequent is false, antecedent should also be false. If consequent is false and antecedent should also be false, then it is contrapositive. So these are the 14 definitions that we are going to understand today. We were going to understand today. First was well-formed formula. Propositions are well-formed formula. Any connective with a proposition is a well-formed formula. Tautology, if a proposition is resulting only one, then it is a tautology. Contradiction, if the proposition is resulting only 0, then it is a contradiction. Contingency, if the proposition is resulting 1 as well as 0, it is contingency. Satisfiable if the proposition resulting any one. If the proposition is having only one in it, it is satisfiable. If all the result of the proposition is 0, it is unsatisfiable. If the proposition is concluding something, it is a premise. If two different premises are concluding something, it is a syllogism. If first proposition implies second, second implies third, and first implies third, then it is a chain rule. If antecedents are true and consequents are true for it, then it is a modus ponens. Now if consequent is also implying the antecedent, then it is a converse. Now negation of antecedent implies negation of consequent is an inverse. If a proposition is always resulting into true, it is a consistent, and if consequent is false, antecedent is also false, then it is contrapositive. So these were the 14 definitions that you should remember, and it's not like they will ask all the 14s in class 11th, but these 14s are the definition in propositional logic that you are going to study in class 11th as well as in class 12th. So these definitions will come again in class 12, so don't worry, we will revise it in class 12, but few things that are really important are, you just focus on it. They are converse, inverse, they are tautology, contradiction, contingency. So these are too much important, right? So you have to work on it. Now the next thing that we are going to discuss is some simple laws of proposition, and that's going to be the last topic of the chapter. So that are simple laws on proposition. So let's see some simple laws on proposition, and then we will see some exercise questions that I have arranged for you that you will do. Okay. So let's see the simple laws of proposition. So there were basically three categories. There are different laws that we will study, and they are known as Boolean laws. So Boolean laws we will study later on, but they are very simple laws of proposition. The first law states that a proposition, operation of a proposition with its negation, and we will do two operations, conjunction and disjunction. So for example, P is a proposition, so P conjunction negation of P will result into 0. Okay, and similarly P disjunction with negation of P will result into 1. So to understand it, let's take a truth table, because only one variable is there will be two combinations. Now some of the students say, sir, there are two variables, P and P negation. Actually P negation is a connective of P itself, so there is only one variable. So there will be two combinations, 0 and 1. So P negation will be 1 and 0. And now let's operate P and P complement. So definitely AND operation, if they are different, they has to be, both of them have to be 1, then only it will be 1. So because any one of them is 0, so it will result into 0. So you can see P and P negation will always result into 0. Now let's talk about P or P negation. So if any one of them is 1, it will result into 1. So you can see P or P negation will always result into 1. This was the first law when you are doing conjunction and disjunction with a variable along with its negation, with a proposition along with its negation. The second law is law with 1 and 0. So first of all, let's see law with 1. So P and 1, that means P conjunction 1 will always result into P, and P disjunction 1 will always result into 1. Now let's see that. Okay, so again I told you there will be two possible combinations and there will be one result. So the second one is 1 only. P can be 0 or P can be 1. Okay, so now let's see P and 1. So P and 1, here you can see the result is P, sorry, I should say 0, and here the result is 1. So the result is actually depending on the input. You can see, so whatsoever input you are giving, that is the result you are getting. So P and 1 or P conjunction 1 will always result into 1. But now let's see, sorry for that, now let's see P or 1, that means P disjunction 1. So let's see that this can be 0 and 1, 0 or 1, and we are doing P or 1. So 0 or 1 is 1, 1 or 1 is 1. So result is always 1. You can see that. Then P conjunction 1 will be P, P disjunction 1 will be 1. And the last law, that is law with 0. This you will do. P conjunction 0 will be 0, and P disjunction 0 will be P. So this you will check, and this was the last law that we are going to discuss. So that was the end of proposition logic. Today we discussed what is a proposition, what are the types of proposition, what are truth tables, and what do you mean by connectives, and the 14 different definitions related to proposition. Now some exercise questions that I had given you. So now in front of your screen you can see some questions from Encoding chapter. Now the first question is normalize the given data by relocating floating point. So it's reallocating, sorry for the spelling mistake, it's reallocating floating point. So you have to reallocate the floating point and according to the normalized form. The second question is write decimal equivalent of following 2's complement. So numbers are represented in 2's complement form, you have to convert it and show the corresponding number. Represent the following number in 2's complement. So here it's given the negative number, and you have to represent it in 2's complement. Represent the following decimal number in binary floating point notation. So here there are two parts in fourth question, A and B. A part will be dealt with 16 bits notation, B part will be dealt with 32 bit notation. And in the A part I have given you 4 questions, and B part I have given you 2. The fifth question is also having two parts, A and B, of 16 bits and 32 bits. The only difference is here binary floating point rotation is given, you have to convert it into decimal number. So these are the 5 questions from Encoding chapter. Now few questions I have given you from Propositional Logic. So it's now in front of your screen. So the first question is answer the following questions, and there are 5 questions on it. What is a proposition? Write its properties. What is a truth table? What are connectives? How are conditional and biconditional different? What is a well-formed formula? Define converse, inverse and contrapositive with examples. So I have given you a few questions related to today's topic. So go through the video one more time and just try to answer these questions. And again I have given you the second question. I have given you few propositions over there. Few of them it's written whether it is a contradiction, a tautology or a contingency. You have to prove that it's a contradiction or it is a tautology and it's a contingency. Similarly the first and the last one you have to prove the LHS is equals to RHS. So these are the exercise questions from your chapter Propositional Logic and Encoding. So I hope you will complete them up, and all the topics till now is clear to you. Among section A only one topic is left, that is your logic gates. That's very interesting and very marks gaining topic, and with that our section A will be completely over, and I can say all the topics which were non-programming related are completely over with logic gates, and now onwards after logic gates we will only focus on your programming part. So I hope you will stay safe at home, you will study harder, you will work harder in this, and I can guarantee you computer is very much marks gaining subject. You can attain very good marks in computer very easily, but few things you have to practice just like mathematics. So that's it for today's video lecture. Hope to meet you in the next video lecture whensoever it will happen. Until then, thank you and have a nice day.